Hello everyone, this is PM Chalapandi here. I would like to welcome you to my today's session. In this session, we are going to discuss about how to solve this problem by using harmonic analysis concept. Okay, let me break down this concept in step-by-step process. So first, let me read out the problem, then I will show you how to solve this problem. Okay, here we are given with a problem as find the Fourier series up to second harmonic to the following data. So we are given with the data, okay, in terms of numerical value, and here our task is we need to find out what is the Fourier series expansion by using harmonic analysis till the second harmonic. This is our task, okay. So to complete this task, we require the following steps. In the first step, we are going to find out what are the basic formula. What are the necessary formula that we require to solve this problem? In the second step, we are going to form a table where we are going to get what are the required information, okay, from the table. And in the third step, we are going to substitute what are the results that we are going to find out in this table that we are going to fit in the formula. After that, after simplification, we are going to find out what is the general Fourier series expansion. Okay, clear. So before we dive into solving this problem, I would like to just recall you why we are solving this problem about by using Fourier series. So in simply, I can say Fourier series is nothing but, suppose if you want to analyze any signal, then you have to use Fourier series because it is helping us to analyze the signal in a simpler way, right? So for this purpose, we are studying Fourier series expansion. So in the previous video, I have uploaded videos by using Fourier series concept for functions, which means if f of x is given in terms of functions, then how to find out the Fourier series expansions that we have studied in brief in the previous problem in previous video that I have uploaded, right? So in this video, if instead of giving f of x, okay, instead of giving, this is very important, instead of giving f of x, so if the problem is given in terms of numerical value, then how to find out the Fourier series expansion? Okay, that we are going to discuss today. Let me dive into the concept, then I will show you in step by step how to solve this problem and how to expand this numerical value by using Fourier series, by using numerical analysis concept, how to expand this data in terms of Fourier series expansion. Okay. Now let us dive into the concept. As already we have discussed, in the first step, we are going to write the formula. Okay, so already we have seen the general Fourier series formula. The same formula I have just expanded here. So first, in the question itself, this word, the second harmonic is very important, which means we have to expand our general Fourier. This is our general Fourier series formula. A naught is divided by 2 plus summation n is equal to 1 to infinity a n cos nx plus summation n is equal to 1 to infinity b n sin nx. So this is the general Fourier series formula. So I just have expanded this general Fourier series formula, okay, up to the second harmonic, because this is we are given to expand, right? So which means you have to substitute n is equal to 1 and 2 for this term, that is your expansion here. Okay, similarly you have to substitute n is equal to 1 and 2 because we have to expand a general Fourier series till the second harmonic. That is why we are just expanding n is equal to 1 and 2. After giving n is equal to 1 and 2 in both terms, it has been expanded like this. So now this is our formula, general Fourier series formula, where we require the Fourier coefficients, right? So now come on, let me check what are the Fourier coefficients that we have here. So here we have A0, A1, A2, B1, B2. So these terms are the Fourier coefficients, right? So these terms are the Fourier coefficients. From so here our task is we need to find out what are the value to these Fourier coefficients at the end. After finding all the values to the Fourier coefficients at the end, we have to substitute that result in this general Fourier series formula. That is our task. Okay, so let me come here. So here we have formulas to find A naught, to find A1, to find A2, B1, B2. So I just have expanded this formula from the general formula, okay, in terms of first harmonic and second harmonic. So here, so to find A naught, we require summation y, right? So to find A1, we require summation y cos x. Similarly, summation y cos 2x and summation y sin x, summation y sin 2x. So all these things that we require to find A0, A1, A2, B1, B2. Okay, look at one more thing in this formula. Here we have to know what is the value of n, capital N. So which is nothing but, so the outcome in your f of x, okay, that is your number of outcomes, right? So in your f of x, that is your capital N. So here we have to check one more thing. The thing is, so first term and the last term, okay, if we have the same, okay, if the last term is repeated, okay, as the first term, then we have to neglect the last term. We have to consider only the first term. So now 1, 2, 3, 4, 5, 6. So this is our capital N. Okay, so clear, you have to make sure first term and the last term are same. Then we have to remove the last term. Understand? So okay. So in that aspect, you have to consider your, you have to count your capital N. It is 6, right? So successfully we have completed the first part. Okay, step 1. So what are the basic things that we require? Okay, that we are going to write in the step 1. Let us come to step 2. Here we have to form a tabular column. So where we are going to find out what are the required things in order to find the value of A0, A1, A2 and B1, B2. So to find A1 we require summation y. To find A0 we require summation y. To find A1 we require this one. For A2 we require this one. For B1 we require this one. For B2 we require this one. Okay. So now we just write what is the value of x, right? We just write what is the value of x. So it is given in the question. So similarly, you have to write what is the value of y. Okay, it is also given in the question itself, right? So here, y is nothing but always here f of x is equal to y, right? So after writing all these things, here we are going to calculate, okay, the another part. So by using calculator, you can easily calculate. So there are 3 types in harmonic analysis. The first type, pi form. Okay, your problem will be given in terms of pi form. In the second type, you will be given your problem in terms of T form. In the third type, you will be given your problem in terms of L form. Okay, understand that. And it is pi form. Okay, as it is quite pi form. So first, we need to convert our calculator in terms of pi form. It is very simple. In your calculator, you can find out radiant mode, right? So when you press your mode, I think 4 times or 3 times, there you can find out radiant. So for radiant, you have to press 2, I think so. So I will upload another video how to use the calculator to find this value. So now by help of calculator, we can find out all these results. So after convert your calculator into radiant mode, you can directly calculate the value in terms of pi form, right? So y value is 0.1. So here you can calculate like 0.1 into cos, then x value is 0. So this bracket is very important. Understand? This bracket is very important. So if you follow this way, your calculator will give the correct answers. In this way, you have to feed all these results. So after feeding all these results, your next job is you need to add. That is called summation y. Summation means we have to add all these y values, right? So it is summation y is equal to 8.7. Similarly, you have to add all these results. You will get another your required things. So after you find the results that you require in the tabulation, let us come to here. So already we have written the necessary formula, okay, to obtain the Fourier series expansion. We have written the necessary formula. So in that formula, you have to substitute your results which you have found here, right? So to find A naught, we have to fit what is the value of summation y. It is 8.7. Is divided by capital N. It is 6. So after simplification, you will get 2.9, right? So similarly, you can find out A1. For A1, you have to fit the value of summation y cos x. It is minus 1.1 and divide by capital N. It is 6, right? So after simplification, you will get this value. Similarly, you have to find out till B2, okay? So after finding all these results, what is your next step? It is very easy. We have already close to the end to solve this problem. Okay, so f of x is the last step. To already we have written the formula to f of x, where we have to substitute only what is the value of a naught, a1, b1, and b2, also a2, right? So let us substitute all these values here. The value first in the first formula, it is a naught is divided by 2. So A naught is what? It is 2.7. When you substitute 2.9 is divided by 2, your answer is 1.45. Your answer is 1.45. So that I have written here directly. Next, let us come to A1. So A1 value is this one and cos x minus B1 value is this one and cos 2x. Then, A2 value is this one and cos 2x. Then B1 value is this one and B2 value is this one. After substituting all these, then your solving process is over. This is what we require. So students, I hope you all have got a clear idea about how to solve this problem by using harmonic analysis. So thank you so much for watching this video. So I will meet you in the next video. Thank you.